Hello everybody, in this video I'll talk about database normalization. Database normalization is the process of breaking large tables which have some kind of issues and problems while inserting or updating the data into smaller tables so that those smaller tables do not have those issues and problems. In terms of database, those issues and problems are known as update anomalies. There are three different kinds of update anomalies. First one is insertion anomaly, second one is update anomaly, third one is deletion anomaly. In case of the insertion anomaly, we will not be able to insert new record. Okay, remember, we not able to insert new record as we do not have all the required values for the attributes. Okay, now we can see this in a simple example. I have created a simple example here. Okay, I have created a simple table, employee information. In this table, 6 different attributes are given: employee ID, employee name, post, salary, country, country code, and 3 different records are there. Okay, I will delete this. Okay, in this table, employee ID and post are made primary key. So according to the functional dependency, we know that all the non-key attributes are dependent upon the primary key. Here primary key is EID and post. Primary key is formed with the combination of 2 attributes, EID and post, and non-key attributes are employee name, ename, that is salary, country, country code. These non-key attributes are dependent upon EID and post. And there we are given some functional dependencies. Employee ID determines ename, employee ID determines country, etc. Now let's talk about insertion anomaly in this table. In this table, if you want to insert new record, suppose we are having information about new employee, that is, okay, let's suppose it's Rita, and okay, she is from Nepal, plus 977. Okay, so in this table we cannot insert this new employee because we do not have value of post for this employee Rita. Post is part of primary key, and we know that primary key cannot be null. Value for primary key must exist. So as we do not know post of Rita, we cannot insert record of Rita to this table. This is because we do not have value of the post, and this kind of issue is known as insertion anomaly. So simply, insertion anomaly is that problem in which we cannot insert record to the table because we do not have sufficient attribute values. Okay, now let's talk about another anomaly, that is update anomaly. Update anomaly, okay, if the table has repeated values, okay, and we update that repeated value in only one record and forgot to update remaining records, then the value of that attribute will become inconsistent in the database. If it is not properly normalized, then the repetition of the record is very possible. Because of certain dependencies, there can be issues. So in that repeated values, we have to update, and we updated those repeated value in only one record and forgot to update in other records. That will create anomalies, that will create inconsistency within the database. Now let's see. Now let's suppose that we know the post of the Rita also. Okay, Rita is also director, okay, and her salary is okay 6,000. Now in this table, what we are seeing is country Nepal is repeated in 2 different tables, and the country code of Nepal is 977. If you want to change this country code of Nepal to 123, we do this here 123, and we forgot to update in this record. What will happen? Nepal will have 2 different country codes. That means that is inconsistency. Now, which country code is correct for Nepal? We cannot say, because in our database table, Nepal is having two different country codes. This happened because information about Nepal is repeated in different records, and we updated only one record and forgot to update remaining records. This is called update anomaly. Update anomaly arises because of redundancy. Okay, now let's talk about another anomaly, that is the deletion anomaly. Deletion anomaly is simple. It is a if when we delete record unnecessary record, but we end up deleting necessary record also. Okay, deletion anomaly is that kind of anomaly which arises when we delete record from the database table. We think that okay, this record is not necessary for us and we delete it. We thought that record is not necessary, but at the same time we will end up deleting necessary values also. Okay, this is called deletion anomaly. Let's see this example. In this table, if we think okay, we do not need record of this first employee E101 and we delete this. Now let's suppose this we do not need, okay, and delete it. What will happen? We delete the record of employee E101 because this record is not necessary for us, but we end up deleting information about the post, information about the country also. We did not want to delete information about the post and country. We just wanted to delete information of the employee E101. But what happened is we lost the information of the post and country also. So this is deletion anomaly. We think that certain values, certain records are not needed for us, so we delete it. But what happens is we not only delete unnecessary record, we delete necessary record also. This is called deletion anomaly. Now, how we can eliminate this kind of anomalies? Insertion anomaly, update anomaly, deletion anomaly. For that, we have to go for normalization. Now, let's see normalization. Normalization is simply a process of breaking original big table, which is having different kind of anomalies, into smaller tables. There are different forms of normalization: first normal form, second normal form, third normal form, Boy's got normal form, fourth normal form, fifth normal form. If we can normalize table up to 3 normal form, it is sufficient. Okay, the first normal form, what it says is all the attributes value must be atomic. Okay, the attributes value must be atomic. That means the value of attribute should not be divided. We should not be able to split the value of attribute to get value for sub attributes. Okay, atomic means undivisible. So the first normal form says all the attribute value must be atomic. Now let's go back to our original record. In this table name Harendra, we cannot split this single value to get value for other attributes. Harendra is a single value, we cannot split it. But here in case of the third record, Sudeep has 2 posts. He is director and actor. We can split this value into 2 different values. One is director, another is actor. We can get 2 different posts for Sudeep. So this post is not atomic because we can split this value into 2 different sub attributes. So first normal form says the attribute value must be atomic, like name given here, like salary. We cannot divide the salary and get other values. We cannot divide these country names to get value for other attributes. So because of this record, this table is not in first normal form. This actor and director value coming for single cell, that cannot happen according to the first normal form. Okay, second normal form, this normal form talks about partial dependency. Database table must not have partial dependency. Partial dependency means non-key attribute are dependent upon part of the key attribute. That should not happen in database tables. Okay, now here in this table, what is given is primary key is made with the help of EID and post. Two different attributes are used to create the primary key, and the functional dependent givens are salary is dependent upon EID and post. But in real world situation, what we know is salary is dependent only on post. That means if we know the value of post, we can know salary also. We do not need employee ID to know the salary. If we know post of employee, then we can know the salary also. That means salary is partially dependent upon this key EID and post. Post is part of this key and salary is dependent upon only the post, not only EID. Similarly, in this functional dependency, EID is dependent upon employee name is dependent upon EID and post. But what we know is if we know the employee's ID, we can know the name of the employee. We do not need the post of employee to name his or her name. That means in that case also we can see the partial dependency. E-name is dependent only on EID. EID is part of this key attribute. So second normal form says there should not be partial dependency in the table. Because of these partial dependencies, salary depending only on the post, we were not able to insert the record of Rita initially because we do not know what was the post of Rita. Post being the part of primary key must have value. It cannot be null. So because of this partial dependency, salary depending only on the post, we are not able to insert information of new employee. So now let's talk about third normal form. Third normal form talks about transitive dependency. Okay, transitives A implies B, B implies C. If you can find functional dependency like this, one attribute A that implies or that determines another attribute B, and that another attribute B determines C. In that case, what we can say is A determines C. That is the transitivity between the attributes. That kind of transitive dependency should not exist in the database table. That is the statement of third normal form. So if we can normalize database table up to these three normal forms, then it is okay. Lots of anomalies will be eliminated if our database table is normalized up to 3NF. Here in this table, the functional dependency given is country code is dependent upon country. Okay, what we know is if we know the employee ID, in that case we can know the country of employee also. If we know the employee ID, we can know employee name, we can know employee's post. Similarly, we can know employee's country. So I will write this here. FD EID determines country. So from these two functional dependency, what we can say is if we know employee ID, we can know country code also. That doesn't happen in real world actually. By employee ID, okay, it's fine, we can know the country. But from the employee ID, it is difficult to know the country code. But if we know the country code, then we can know the, if we know the country, then we can know country code. So we can see the transitivity between these three attributes. Employee ID determines country, country determines country code. So what we can say is employee ID also determines country code. So this is the transitivity that exists within this table. So if transitivity exists in the table, then that table is not in third normal form. Okay, so we saw update anomaly, the record of Nepal been repeated here, and if we try to change the record country code of Nepal, we saw the inconsistency for the country code for Nepal. So now let's change this to original one, 977. So in this way we can check whether our database table contains anomalies or not. If it contains partial dependency, then it is not in 2NF. If it contains transitive dependency, then the database table is not in 3NF. Now let's normalize this table up to the 3 normal form. So first we will be checking whether the given table is in first normal form or not. Okay, according to first normal form, all the attribute values must be atomic. So in this case, okay, what I can do is I can make 2 different posts and specify director and actor for that Sudeep, but I'm not going to do it here. So instead I will jump to the second normal form here. So in this table we are finding partial dependency. The the salary is dependent on post, and this e-name dependent upon employee ID, country depends on EID. So first we will be removing partial dependency and we will make our relations to the 2NF. So first I will be creating relation R1, and this will contain post and salary. Because of this salary we had this partial dependency, so we will remove those attributes because of which partial dependency exists in the table. So for this table R1 I will make post as the primary key. So I will check another attributes which created the partial dependency. Here employee name is dependent upon EID, so I will remove this also. If we know the employee ID, we can know country also, so I remove this country from the original table also, but the country code depends upon country, so I will be putting this here, country code. Okay, R2. Why we created R2 is e-name is dependent upon EID, that is the partial dependency. Country is also dependent upon EID, that is also the partial dependency in the original table. So from that original table we derived those attributes which created the partial dependency. We derived the country code here also because country code is dependent upon country. Now what left in our original relation is, let's suppose is R3, it left with EID and post only, because we have considered other attributes and kept in relation R1 and R2. Now this relation consists EID and post, and these are the part of the primary key. Now we have to check whether this construction of 3 relations have any kind of anomaly or not. So let's talk about the insertion anomaly. Can we insert information about employee and we're having employee ID and name only? We can, because we have employee ID, that is the value for the primary key. We are having the value for primary key, so we can insert employee information. Can we insert new post? Sure, why not? Because post is the primary key and we have the value for the post, so we can insert new post also. So there is no insertion anomaly. We cannot insert information about the country because we do not have employee. If we do not have employee, we cannot insert country. Okay, we'll talk about this a little bit. And we can associate employee and post with this table. This table will show which employee has which post. And if we want to know the salary of particular employee, first we have to know employee ID, then we have to know post of that employee, then from R1 table we can know the salary of that employee. So that means the partial dependency is gone. So remember, if the table has primary key formed with only one attribute, then there will be no partial dependency. Okay, if the primary key is formed by composite attributes, combination of different attributes are used, and in that case partial dependency may exist. So these 3 tables are in 2NF, but I have already said we cannot insert information about country also. Suppose new country came, America, and country code is something, okay, 200. We cannot insert information of that country because we do not have employee. To insert the country code and country information, we need employee, because employee ID is compulsory. Employee ID is primary key. But this R2 relationship, that is in 2NF, but it is not in 3NF, because if we know EID, we know country. Okay, if we know EID, we know country, and if we know country, we know country code. That means there is the existence of transitivity among EID, country, and country code. So we have to check this problem and make this table into 3NF. because this table R2 contains transitive dependency. That means it is not in 3NF. So what we have to do is we have to create another relations R4, and we'll, because of which attributes transitivity came, it is country and country code. So we will remove these attributes because of which transitivity came and store in the new relation, and relation R4, let's make the country as the primary key. Now in this table we can store information about any country, because we do not need employee information to store information about the country. So R4 is fine for country. Now what remained in R2? R2 is remained with EID, ename and country. Okay, so in this way we have created that employee ID will be the primary key for R2. So our final tables will be R1, that consisting of post and salary, then R2 containing EID, ename, country, then R3 containing EID and post. Okay, in this way we break original table into smaller tables. Okay, break original table into smaller ones to remove the anomalies. So in this way we remove first partial dependency and make our database into 2NF. Then we check if the table contains any kind of transitivity or not. If the table contains transitivity, we will remove that also, transitive dependency, by breaking that original table. So in this way we do the normalization of database table up to the 3 normal form. Thank you very much for watching this video.